Hey guys, welcome back. Um, Yesterday was the snow day, like I call it, but today was unexpected virtual day. So I know that we planned on a Jeopardy game. Unfortunately, that plan also has to postpone, and it seems like we have to end up taking the test on Tuesday after all, particularly due to the fact that we have all, the review game sessions being postponed until this day, and it's not ideal to do the game on a virtual day. I promise you that, because when everyone's online, just getting them set up is going to take a long time, and it's not going to work out pretty when nobody is with me to kind of give me the feedback on what the answer is. And if everyone's just shouting answers online, it's not going to work out well. Now, I'm not sure if we have to do the if I don't know how to make this feasible, but the best way to probably that I could think of off the top of my head is really just to play just the game on Monday, and then Tuesday will be the day that we take the test, and Wednesday we'll just wrap up with the game, and I think that's gonna be it. I think that's the ideal case because of the virtual day today. So, but today what you're gonna do is you're just gonna watch the video of me going over the study guide for me, just checking your answers. So there's no homework, nothing like that. Just study over your materials. It's not gonna be any different from what you see already at the moment right here. Okay. So I had some questions and requests to have the answer key uploaded so you guys can all see. But also I'm going to give you a detailed explanation as to how to do this. So consider the polynomial division below, x cubed minus 2x squared minus 4 divided by x minus 2. Solve for the above by using the long division. So what that means for me is that I'm going to do this in terms of showing work. So I'm going to write it like that. You can leave yourself a little gap here if that really helps you out. Like, for example, I can write minus 4 at the end, just to indicate that there's like nothing in between the x squared and the 4. But that's completely up to you. Now, the number that you should put up here is x squared, obviously, because x fits in x cubed x squared amount of times. X cubed, and then you write minus x2x squared. And what do you notice is that these two will completely cancel each other out. So then you bring down the minus 4 and say, okay, my final answer from this is x squared minus 4 over x minus 2. The way that we write it is we always put our remainder over on top over our divisor. This will be the complete answer for part A. Solve by using synthetic division. Now, synthetic division, you will have to replace that missing gap with a 0. And here it's always when you solve for the 0 here. So when x minus 2 is equal to 0, if that was our divisor, you would have to put the 2. Simply put, change the signs, right? Bring down the 1, 2, 0, 0, 0, 0, 0. Oh, I'm sorry, not 0, negative 4. What am I doing? So again, you get the same thing where this was just simply x squared. This means a remainder of minus 4. Put it over our divisor and say x minus 2. I think the better way to put it is like this. So there we go. So we should be able to get the exact same thing for a long and synthetic division. Now the last part is when you're doing the remainder theorem. What is a remainder when this is divided by that without doing the division part? It's just simply f of 2. When you compute the value in which the factor, when you solve for the 0, when you plug it in, whatever the value that you get as a result of that is going to be a remainder. So that means 2 cubed minus 2 squared minus 4. In terms of showing work, this is sufficient enough. 8 minus 4, well, that's a 0, so that's negative 4. And look at that. The remainder for all of these guys turned out to be 0 for every single one of these cases, so I think I'm good. Number 2, consider the graph below. Oh, I'm sorry. This graph is actually missing the picture, so I'm actually going to copy it down one more time. Just give me 1 second. Let's see. All right, so the value is at negative 4, negative 1, and this is 72, and 1, and positive 3. And I believe the graph would look something like this. All right, so then I told you that there's a multiplicity at 2 locations. Well, actually, just 2 multiplicity of both mix of odd and even. there is multiplicity of 3 at x equals negative 1, and there's multiplicity of 2 at x equals 3. This is what I'm expecting you guys to write down. What is the end behavior of the graph? As x approaches negative infinity, y approaches positive. X approaches positive, y approaches negative. Now, with this kind of end behavior and with the number of zeros, what is the least degree function? Well, take a look at where the zeros are hit. That's multiplicity of 1, and that's at least counting ones. This you have to count 3 times because of multiplicity of 3. That's 1, and that's 2. So in other words, 1, 3, 1, 2. If you add them all up, that will give me a total 0 of x to the 7th power. Of course, there could be more multiplicities. Like for example, this could be a multiplicity of 5, 7, or beyond, or this could be 4, 6, or beyond. But we're talking about the least degree polynomial function, so it has to be x to the 7th. This will hold all the zeros indicated by the function above. Now the last part is to incorporate this end behavior to the graph, so which means that if it's going up and down, you just need to put a negative sign in front. In other words, that is going to be your leading term. The least degree function of the graph will be the 7th, but your signs have to be negative because of the end behavior. Write down the function in a factor format. Okay, well, if I take all the zeros from above, we should be able to get x plus 4 as one of my zeros, and then x plus 1 cubed because of multiplicity of 3, x minus 3 squared because of multiplicity of 2x minus 3, and also x minus 1. Right, and then there's a negative sign in the very front of that because of this negative sign and end behavior here. But the last part is that I asked you guys to pay attention to, which is the y-intercept at 72. Now, if you were to calculate the y-intercept at this stage, you get a negative 4, 1 cubed, negative 3 squared times negative 1. That's negative 4 times 9 times negative 1, which gives you a positive 36. But the y-intercept in this case is 72. In other words, we need to vertically stretch this by factor of 2 in order for this 36 to become 72 as my y-intercept. So my final answer here, you need to input the coefficient as 2 in the very beginning. So my final answer should look something like this. Just have to put the 2 in the front there. That should take care of the y-intercept problem. All right, number 3. Use the remainder theorem / synthetic division to find the zeros, then factor it out completely, show all your work. All right, so for this one, what you're going to do for me is that you're going to be plugging in the zeros for this, so f of whatever, and looking for the 0. Now, I believe that one of the zeros that happened here, let me see. I tend to give you ones or negative ones, but after a lot of trials and errors here, let's see. Okay, one of the zeros definitely did happen to be at 1, so I'm going to just use 1. And 1 here, negative 1, negative 4, 2, 12, and negative 9. Of course, showing your work would be all this. Negative 1, negative 1, negative 5, negative 5, negative 3, 9, 9, 0. I'm going to use another remainder theorem, and let's try doing ones one more time and see what happens. Negative 6, 6, 3. Ooh, I think I made a mistake here. Negative 1, negative 6. That's negative 6, and that's negative 9. Negative 9, and that's 0. So the remainder of 0. So I get 2 x-intercepts, or actually this one distinct x-intercept with a multiplicity of 2. And I get a quadratic that says negative x squared minus 6x minus 9. So all of you guys were getting really confused about this, but all you got to do is really factor out the negative sign and say, okay, x squared plus 6x plus 9. And so that will be x plus 3 squared. So in other words, if I were to factor it out completely, my final answer would be negative x plus 3 squared times x minus 1 squared. The x minus 1 squared comes from the fact that I get x minus 1 twice from here and here. The zeros in that, therefore, if I were to write it down right underneath it, x would be at negative 3 and x would be at 1. The next question is, what is a leading term? Well, the leading term is indicated by the very first term in the polynomial. It's negative x to the 4th. The end behaviors, therefore, will be when x is negative infinity, y is negative infinity. When x is approaching positive infinity, y is also going to negative infinity, indicated by the leading coefficient as well as the leading degree. All right, sketch the function. Now I know that I have to be both going down, and negative 3 and a positive 1 is a multiplicity of 2, so it bounces off, and your y-intercept of negative 9 is just a freebie. So if I were to plot it, I'm looking at anywhere that looks like that. An M shape with multiplicity of 2 at both of these locations, so it bounces here and there. Number 4, the remainder theorem. If there's a function of p of x such that p of 3 is equal to 0. Guys, what that means is that when you plug in 3, you get a 0. This obviously means a remainder. So anything that has some of the things where it says x, like for example b, 3 becomes remainder. That's not even a choice. Like that can't be possible. And that 3 represents one of our zeros. Or the factor, if you make it, it should be x minus 3. So A is definitely an answer, and C is also definitely an answer. That is what this means, that you get a 0 at x equals 3, and the factor is x minus 3. There's no multiplicity, can't tell that from this alone. X equals 0 is one of the x-intercepts. Well, no, 3 is one of the x-intercepts. P of x is not divisible. Well, it certainly is if the remainder is 0. So none of these is going to be true. So only A and C will be the correct choices. All right, suppose that Erica wanted to try to find one of the zeros of the function. So using the remainder theorem, Erica calculated for that. What does this mean? It means that x minus 1 is not a factor. And you get a remainder of 8 when f of x is divided by x minus 1. In a full extent, I want to describe both what 1 and 8 means. What do these two things mean? It means that the 1, you try for one of the zeros and say x minus 1 is one of our factors, or x is 1. But it doesn't work because your remainder is going to be 8. So the remainder is 8. It's x minus 1 is not a factor. Those are the things, key points in which what I'm looking for. Don't just say that the remainder is 8 because that's way too simple. Also describe what f of 1 will represent. What does 1 represent in terms of the function? By plugging in a different value, f of negative 1, Erica calculated the value to be 0, which means I can literally copy and paste whatever I said for part B here. X plus 1 is a factor because you get a remainder of 0. Okay? So what should she do in order to completely factor the polynomial? Well, then she should use synthetic division and solve the function completely. Okay, so my function was x cubed minus 5x squared plus 3x plus 9. So with that function here, I am taking the f of negative 1, in other words, my x value to be negative 1, and using the synthetic division here. So of course I want to erase all of my, I'm going to write 1 here just to indicate that it's 1x cubed. 1x cubed. And I'm going to erase all of these letters here. So x cubed is gone, x squared is gone, and x is gone. And then I'm going to use synthetic division with this and say, okay, I'm bringing down the 1, negative 6, 6, 9, negative 9, 0. And then this becomes x squared minus 6x plus 9. Factor that out, I'll get x minus 3 squared. So, solve for the factors of the function. I would say x minus 3 squared times x plus 1, because that, put in a factor form, I should be able to get that. See, I'm telling you, it's a handful, but using a remainder, like remainder theorem and the synthetic division is the biggest key point takeaway from this chapter. All right, the last part. Suppose that there is a function g of x such that it has zeros in the following locations. I have a 1, negative 1, 4i, and negative 1 minus 2i. How many zeros does this function have? Well, see, it turns out that it's going to have a total of 5 zeros here. Well, actually, technically speaking, there's 1 real zeros, if I want to be more specific with that. 1 real zero and 4 imaginary. solutions. All right, so are there any zero that is missing from the list? Well, absolutely, because remember, complex roots comes in pairs, which means the 4i, the negative 4i is missing, negative 1 minus 2i, the negative 1 plus 2i is missing. So these two are the ones that's missing. And you want to count 1, 2, 3, 4, 5 in total. Therefore, it matches the total sum of the real plus imaginary roots. Using your answer from part A, the least degree function that could hold all the zeros is obviously x to the fifth, because you need to have fifth degree function to contain 5 zeros at least, at the bare minimum. The last part is the factor format is given to us as that. Okay, well that tells me a lot of things. First of all, a negative sign, along with the leading term, when you FOIL it out, you get x to the fifth plus blah, 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 but I don't really care about the rest. This leading term tells me that my end behavior as x approaches negative infinity, y should approach positive infinity. As x approaches positive infinity, y should approach negative infinity, which means I'm going down this way. The y-intercept here is going to be very huge, but once you solve for it, I do believe you get some sort of a negative number here. To be more specific, negative 80. One of the roots, that's the only one real zero that I get is negative 1. So if you were to draw a straight line down like this, or if you want it to be a little bit more fancy and just kind of do like, hey, let's me just do kind of like a little curve here, then just do something like that, it's no problem, because, as long as you indicate that the zero there, you go straight through, then I don't think we're going to have any problem. Your end behavior matches along with your y-intercept, so I believe that's going to be fine. All right, so again, no homework over the weekend. How nice is that? Your test on Tuesday. I've decided I'm not going to change my mind anymore because, with all the schedule change, unless another big snowstorm is coming up, I don't think we're going to have any problem with that. So just enjoy your weekend. Make sure you study. If you have any questions, just let me know. Just reach me through Schoology. Have a great day, everybody.